Hello, I want to show you how to construct a proper line graph. We use a lot of line graphs in science to show a relationship, to show a visual or pictorial relationship between two variables or sets of data. In other words, they show how one thing or variable is affected by another variable and how the variables change depending on one another. Line graphs are useful for showing trends in data. This means that they show how one variable is affected by the other as the variable increases or decreases. One way to remember which data goes on which axis is dry mix. Dry refers to the dependent variable. This is the variable that responds to the change to the independent variable, and this is graphed on the y-axis. The dependent variable is the variable that you measure. Mix refers to the independent variable, or the variable that is manipulated or purposefully changed in your investigation, and this is graphed on the x-axis. The x-axis is the horizontal axis, which goes left to right, and the y-axis is your vertical axis, which goes up and down. Every graph must include a title, and the y and the x-axis must be labeled. The data that's going to be used in this example is from an investigation of how drop height affects bounce height. So as drop height was manipulated or purposefully changed, the bounce height was recorded. This is the responding variable, or the variable that is measured, and this is your dependent variable. Again, every graph must include a title, and the title should show and reflect the relationship between the dependent and the independent variable. The independent variable in this case was drop height, and by changing drop height, how bounce height was affected. Before graphing the data, you need to decide on an appropriate scale for each axis. The scale is the numbers used on the axis of the graph, and the scale usually begins at 0. The scale of the graph is very important. You can see that my scale for the x-axis goes from 0 to 20 centimeters. Notice how centimeters is included with the labeling of the x-axis. If the unit of measurement is not included when labeling each axis, then the numbers have no value or meaning to what they represent. The scale on the y-axis goes from 0 to 40. It's also important to select an appropriate interval for your graph. The interval is the amount of space between one number and the next, or one type of data and the next. On the x-axis and the y-axis, the interval is 2 spaces, or 2 lines. It's important to select an appropriate interval so that your graph is easy to interpret and it's easy to make inferences and interpret your data. Next, you need to plot the data points. As you recall, we are graphing how drop height affects bounce height. The data we are using from the data table show that when the drop height was 5 centimeters, that the ball bounced 10 centimeters. When the ball was dropped from 10 centimeters, the ball dropped 20 centimeters. When the ball was dropped from 15 centimeters, it dropped 30 centimeters. And finally, the last drop was from 20 centimeters, and the ball bounced 40 centimeters. Finally, you connect the data points with a line. And now you have a visual representation of how drop height affects bounce height. And that relationship shows that as drop height increases, bounce height increases.